Okay, I'm going to be continuing with every exam question that has ever been asked, and I'm going to be looking at angles now, and this is a huge topic, so I'm going to break it down into a few different videos. There'll be one on triangles and parallel lines, one on polygons, and then a big one at the end on circle theorems. Like I always say, if you do want to use this document, it is linked in the description. It is a fully hyperlinked document, which means all these things down here are buttons that take you back and forth to different sections of it. So this one is a non-calculator paper. It says the diagram shows triangle ABC, and we've got all of this information that ADB is a straight line, which we can see, and the size of angle DCB to the ratio of the size of angle DCB to the size of angle ACD is 2 to 1. So this is DCB and this is ACD, which means that this angle that we have here, I'm going to call it X, and this one is double the size of that, which is 2x. So I know that all the angles in a triangle are going to add to 180, so I'm going to add them all up, which is 2x plus x plus 75 plus 51. That has to be equal to 180. So the 2x plus x is 3x, and then the 75 plus 51, add them together with whatever method you like, and you get 126. So I'm now going to do 180, take away 126. That is going to be 54. Again, you can do whatever method you want for that. And my last thing is to do 54 divided by 3. And 54 divided by 3 is 18. If you need to do the bus stop method for that, that is absolutely fine. So that means that this angle here is 18 degrees, and this angle here is therefore 36 degrees, because 18 times 2 is 36. Now, it's interesting that I was able to do some of that maths before I'd even read what the question is, and that's often a really good technique for when you do these kinds of things. So we want to work out the size of angle BDC. That means you go from B to D to C. It means it's the angle that's at the middle letter. So this is the angle that I want to find that is at the top here. Well, if you have a look at the shape that we've got, it is just a smaller triangle where we can find out what the missing angle is that we have there. So the angle that I'm looking for, which is angle BDC, it would be 180 for the whole triangle, and I'm going to take away the 36 that we've just worked out and the 51 to find out what is left over. Well, if I add the 51 and the 36 together first, I get 87. So it's 180, take away 87. Well, 180 take away 80 is 100, and take away the extra 7, and we get 93 degrees. So the angle we're looking for is 93 degrees, which is the right answer that we've got here. Okay, so the next question that we've got is to do with parallel lines, and before I start this one, there are so many ways of answering these questions that you might do it differently to me, so don't worry if you're doing it in a different way. It's just the way that my mind sees this. Okay, so it says that ABCD is a parallelogram, and EDC is a straight line. Again, we can just see that. F is the point on the line AD, so that BFE is a straight line. Great, all pretty obvious so far. Angle EFD is 35 and angle DCB is 75. Well, all of this stuff here is kind of pointless. It just says, show that angle ABF is equal to 70 degrees. So this is the one that I'm aiming for, not that one there. ABF, remember it's the middle letter that we're looking for the angle. So this is the one that I'm going to try and do. And it does say give a reason for each stage of your working. Now you can either draw them on the diagram and annotate it with reasons like angles on a blah blah blah, or you can actually do what I'm going to do, which is to write them with the reasons next to it. So I'm going to start out, I'm actually going to find out this angle that we've got here, which is going to be 35. I think that one might be useful. So I'm going to say that angle AFB is 35 degrees, and my reason for that is that they are vertically opposite, and we know that vertically opposite angles are equal. Now that I've worked out that one, I actually think I can work out what this one over here is. This one is going to be 75 degrees because it is a parallelogram that we've got here, and opposite angles in a parallelogram are equal to each other. So angle FAB, remember the A is in the middle there, is 75 degrees, and we can just say that they are opposite angles in a parallelogram. A lot of writing in these angles, reasons, questions. And then the one that I'm looking for is going to be angle ABF. So it's going to be 180, because they add up to 180 for a triangle, minus 75 minus 35. So that's going to be 180 minus 110, which is equal to 70 degrees. And the reason for this is the angles in a triangle add to 180 degrees. So we've shown that the angle ABF is 70 degrees, and we've given a reason for each stage in our working. So I'm going to just show you the mark scheme because there's some interesting things here. When you obviously when you write down the reasons, the things that must be there are these bits that are underlined. So for example, when you do the vertically opposite angles are equal, you just need to say vertically opposite, but you could say opposite angles or vertically opposite. So the ones that are underlined are the ones that have to be there. So I'll just double check we've got them right. Opposite angles and parallelogram we had vertically opposite, or we did have vertically opposite angles. And I don't know what it says about angles in a triangle. I don't think we even needed to use that one here. Maybe I'm just not spotting it. Yeah, allied angles, sum to 180, whatever. We've got it for the one that we used, and we know that we've got it right. Okay, we're going to try and find out the size of angle X in this diagram that we've got here, and they've told us that these two are parallel to each other. So there are lots and lots of different ways to doing this one. Probably my favourite way of doing this one is to add in a parallel line that we've got like this. And if you add in that parallel line very quickly, you can see that these are equal, so that's 35, and these are equal, so that's 25. So X is just 35 plus 25, which is 60 degrees. But I don't think many people are going to spot that you can add in this parallel line like this. So I'm going to show you an alternative way about how you might do this question. I think most people would probably go about finding this angle that they've got here. It's a calculator paper, so I'm going to do it really speedily. I'm going to do 180, I'll take away 110 and 25 because they're on a straight line that we've got there. And I'm going to say that that one is 45 degrees that we have. So I'm going to now say that angle BEG is equal to 45 degrees, and the reason is angles on a straight line. Now there's different angles that you could try and work out here. I actually think we could probably go straight to working out what this angle here is. I think we could actually work out what this angle is, because we know, I'll tell you what, I'm not going to do that. I'm going to find out this angle. I think this is the way most students would prefer to do this. I'm going to say that this angle, because of this shape that we've got here, is 70 degrees. And the reason that ABE is equal to 70 degrees is because of co-interior angles. And co-interior angles add to 180. What I mean by that is this one and this one need to add to 180 because they're inside that shape that we've got there. Now I'm going to find out what this one at the top is. So I have the 70 plus 35, that's 105. So that must be 75 degrees. So I'm going to say now that angle EBG is equal to 75 degrees, and that's angles on a line, angles on a straight line. And then my last one is to work out what X is equal to. Well, X is going to be equal to 75 plus 45 taking away from 180. So I'm going to do 75 plus 45, that's 120. I'll do 180, take away 120, which is equal to 60 degrees. So X is equal to 60 degrees. And the reason I used for that was angles in a triangle add to 180. Angles in a triangle add to 180. So I think my very first one that I did of splitting this up into two and saying they were alternate and they were alternate, so it's 60, it's probably a lot quicker. But just in case you didn't see it this way, this is how I also could have done this question. We also could have said that these two were co-interior to these two, so that could have told me that was 75. Tons and tons of ways of doing these, so don't worry if you get a different answer to me. But we do have 60, and we've got all of these different kinds of reasons down here that you could have said. Okay, we have ADC as a triangle, AED and ABC are parallel lines, pretty easy to see. EBC is 148 and ADC is 63. Work out the size of angle EAB. So we're going to try and find out this one that we have at the top, and it says we give a reason for each stage of the working. Well, I'm going to be able to immediately find out what this one is here. So this is a non-calculator one, so I'm going to work out 180 take away 148. The reason I'm doing that is because these two are co-interior angles. When I do 180 take away 48, I get 32 degrees. So this is 32 degrees. So angle BCD is equal to 32 degrees, and the reason is co-interior angles. You could say that they add to 180, but you don't need to have that bit in the underlined part. And then if you look on the large shape that we've got here, we can actually just go straight away to find out what angle A is at the top, because we've got a large triangle. 63 and 32, they need to get taken away from 180. So I'll add my 63 and 32 together first, which is 95, and then I'll do 180, take away 95, which is going to be 85 degrees. So this means that angle EAB is equal to 85 degrees, and that's because angles in a triangle. Angles in a triangle add to 180. So let's double check that we've got this right. The answer was 85, and we had some reasons here. I'm going to write that it's 85 on the diagram so that we've got it recorded. There it is with 85, and you need to have two reasons to get both of these, and you can see angles in a triangle, that's all that's really need to be said here. Okay, next set of questions are all about polygons, so I'm going to split that into a separate video.